Good afternoon, this is Mrs. Michek again, and we're going to be talking about mole fraction. This is the last calculation that we're going to be doing for solutions. So mole fraction is just that, it's a fraction. One important thing to note, again, it's a fraction. It is not a percentage. So when you get your final answer, you should not multiply it by 100. Another thing, the mole fraction is represented by an x, and you will be finding x of a particular part of your solution. In this case, I represented it with an a, so I represented x of part A of our solution. A lot of times that would be the solute, but not necessarily. Sometimes you might be finding the mole fraction of a gaseous solution, in which case there's not necessarily a solute or solvent. Anyways, the mole fraction is a fraction of the moles in solution. Number of moles are represented by an N, so we have the number of moles of solute A divided by the total number of moles. Notice that I wrote a dot here because in solutions like gaseous solutions, you might have more than more than two components. In the room that you are breathing in currently, you have more than two gases. So you have the carbon dioxide that you are breathing out, you have the oxygen that you are breathing in, you also have nitrogen, you have trace amounts of argon, so that's 4 already. So in that case, you would have at least 4 on the bottom. And if you were finding the mole fraction of the carbon dioxide that you are breathing out, you would only have carbon dioxide on the top. Anyways, a lot of times we are finding the mole fraction of solutions that are similar to the ones that we've been working with, where you have a solute a solid or a liquid solute dissolved in water, in which case you would have your solid or liquid solute moles on the top. Notice that it's the total number on the bottom, so that would be also written right here, plus the number of if it's dissolved in water, you would have your number of moles of water right here. Alright, we're going to go ahead and do a practice problem. As has been the case the past several problems that we've done, we're going to go ahead and jump into one that is not just moles divided by the total number of moles. So, we're calculating the mole fraction of a solution containing 250 grams of NaCl dissolved in 1,000 grams of water. Alright, I'm going to write our formula over here. So, I want to find the mole fraction of NaCl. So, I'm going to have X of NaCl is equal to the number of moles of NaCl divided by, remember our total number of moles is on the bottom, so that's going to be equal to the number of moles of NaCl plus, notice we've got addition to find the total, we add it together, so the number of moles of NaCl plus the number of moles of water. In order to find those, we don't have moles right now. We are given grams of both. So I'm going to have to make some conversions. You might know the molar mass of water off the top of your head. You may not know the number or the molar mass of NaCl off the top of your head. So we're going to find that one. NaCl, 1 sodium, periodic table tells us that the molar mass of sodium is 22.99 grams per mole. Chlorine, we've got one of them, 35.45 We're going to add those together. To get 58.44. Grams per mole. And I'm going to come down here and do my conversions. So I'm given 250 grams of NaCl. I'm going to put that over 1. Since grams are on the top, I need grams to be on the bottom right here. 58.44 grams per 1 mole of NaCl. And when I get that, I get 4.28 moles of NaCl. So notice that is equal to N of my NaCl. I additionally need to find the number of moles of water. I have 1,000 grams of water. The molar mass of water is 18.016. So, I'm going to have 1 mole of water divided by 18.016 grams of water. So I do my 1,000 multiplied by 1 over 18.016, and I get 55.51. Moles of H2O. Now all I need to do is plug those numbers in up here. So I'll have the X of NaCl is equal to, notice that the number of moles of NaCl is written twice, here and here. So I'm going to have 4.28 moles divided by 4.28 again. Told you, but I didn't do it at first. Now I'm going to add my 55.51. And this is moles. Since we're adding, I'm going to have moles divided by moles. That'll cancel. The mole fraction doesn't have a unit. So we'll just get X is equal to no units. I do recommend putting parentheses around the bottom. So I'm going to put 4.28 divided by parentheses 4.28 plus 55.51, and I get 0.72, or excuse me, 0.072. And again, no units. It's hard and very tempting to write some kind of unit there. No units should go there. All right, we're going to move on to the next problem. If you felt pretty confident about this problem, you can look at what the next problem is and try and do it on your own. I will tell you the next problem is a little bit different. So I'd make sure you have a grasp on it before you try and do it entirely on your own, and then check your answer at the end. All right, so this next problem wants to know the mole fraction of a 25% by mass aqueous solution of KCl. All right, so this problem gives us percent by mass. When it tells us percent by mass, we can make the assumption that in a 100 gram solution, 25 of those grams are KCl. If it's a 25% by mass solution of KCl. What is the rest of the solution? Well, it tells us it's an aqueous solution. If you remember, aqueous means that it's been dissolved in water. So, 75 grams is going to be water. All right. Now, I again don't have all of the pieces in order to find the mole fraction. So my mole fraction is going to be X of KCl is equal to the number of moles of KCl divided by the number of moles of KCl plus the number of moles of water. But I don't have the number of moles yet. I only have the mass. So I still need to convert both of these to moles. In order to convert KCl to moles, I need to find the molar mass of KCl. So I'm going to do that over here. KCl. I have 1 potassium, 1 chlorine. Potassium, I think is 39.1. I'm going to double check though. It's not one that I have memorized. Yep, 39.1. Add those together. And I get 74.55. And those units are grams per mole. So my 74.55 grams of KCl is going to go on the bottom with my 1 mole of KCl on the top. And I get 0.34. Now I can do the same thing with water. At this point, many of you likely have the molar mass of water memorized. I'm going to erase this formula so I have enough room. 18.016 grams of H2O. And I get 4.16. All right, take a minute to make sure you have all of that written down. We can use those numbers to plug into our mole fraction formula. All right, I'm going to erase this. going to write this 0.34 is the N of KCl. And this is the N of H2O. And I'll write out or erase all of my math for that so we have enough room to work with. Remembering our formula, X of KCl is equal to the number of moles of KCl divided by the number of moles of KCl plus the number of moles of water. I can now plug in the things that I know, which are the number of moles of KCl as 0.34 moles divided by 0.34 moles plus the number of moles of water, 4.16 moles. And I get 0.0755, which I'm going to round to 6. So 0.076. And again, there are no units. So the mole fraction of KCl in this 25% by mass solution of KCl is 0.076. And I hope that that's been helpful for the mole fraction. Enjoy!